Hello and welcome to episode 60, an AfterMaths episode of the Primary Maths podcast, the show where we talk all things primary maths. I'm John Cripwell.
And I'm Becky Brown.
Hello, Becky. How are you this week?
Hi, John. Yeah, I'm good, thank you. I've had a lovely week. The sun has shone a little bit here this week, which is nice. Spring has finally sprung, which is lovely. How's your week been?
Yeah, similar. It's we had a couple of nice days. I've seen the sun. It would be nice to feel it at some point. You know, that's always the thing that I used to like when I was on break duty, playground duty. That sort of first day when you could actually feel the sun breaking through seemed to make break duties and playground duties just feel a bit more bearable, I think.
Definitely.
So, yeah, although looking out the window now, it's gone back to being grey and very, very windy. And we all know what a windy day does in a school.
Yeah, it's amazing, isn't it? It's like a windy day and a full moon combined. It's like, wow, what's happened here?
I wonder if there's any academic research that's gone into the effects of windy days in school on behaviour and attainment and teacher well-being. Probably they're the three areas that I think it's most likely to affect.
We should definitely do some. That would be great, wouldn't it?
Yeah, if anybody would like to volunteer to run that study in their schools, just get in touch. Primary Maths Podcast at twinkle.co.uk. Because just something about it, something about a windy day just sends the kids absolutely wappy, doesn't it?
Yeah, definitely.
And on top of that, Becky, it is again Friday the 13th.
Another one so quickly. We only just got over the last one.
Yeah. So this year, 2026, we've got Friday the 13th in both February and March. But the next one, you might be relieved or you might not. You might really love the Friday the 13th. The next one is not until November.
But still 3 this year. That's
3, yeah, which is the maximum possible in a year. There you go. So,
I like that.
Yeah, that's not just off the top of my head. I did do a little research. The most Friday the 13th that you can have in a year is 3, and we have got 3 of them this year. I'm not sure whether we get 3 every year or whether 2026 is particularly lucky. But we've definitely got 3 this year. And on top of that, it's also my brother's birthday. So happy birthday to my brother. Friday the 13th is a very, very appropriate day for him to have his birthday. Yeah, happy birthday, Jay. So this week, Becky, what have we been up to? We had an interview episode earlier this week with Will McLoughlin, all about direct instruction and mathematical thinking. And I'll be honest, Becky, I thought I was going to disagree with him quite a lot, but actually, as we got into the conversation and he sort of explained his thinking around it a little bit more, I found that it wasn't completely opposed to sort of my own thoughts and approaches towards teaching maths.
Yeah, there was quite a lot to unpack in that episode, John. It was a really good listen. And I think, it's that going a bit deeper with the conversation was really interesting because I think I felt the same. Lots of things that were maybe touched upon on the surface, wasn't sure where it was going. But when Will explained in a bit more detail, it was like, yeah, I get that. I agree with that. So yeah, really interesting listen. It's episode 59, I think, if the listeners want to go and find it.
Yes, episode 59 with Will McLoughlin, direct instruction. And as you say, just things to think about, I think. It's always that thing with education, isn't it? We can sometimes get pulled into thinking that things are totally black and white or a dichotomy of I do it this way or that way. But as we seem to always find out, there's bits to take from everything, isn't there? And there was definitely things that Will talked about that I thought, yeah, absolutely, that's a really good way to approach that.
Yeah, definitely. And I think one of the best things, John, when you're talking to your guests is thinking about their experiences and how that's shaped what they're working on. I know Will was talking about Kumon, wasn't he, and doing that. And that's something I'm quite familiar with from doing tutoring at various times. And I thought that was quite interesting how that sort of played into his experiences later.
Yeah, absolutely. So if you haven't listened to that show, maybe it's because you haven't yet subscribed. So if I were you, I would heartily recommend just taking a moment, going and finding the Primary Maths podcast on whichever platform, or as ever, all of them, and just subscribing so that you never miss an episode. And if you wanted to give us a little review while you were there, we wouldn't say no to that either, would we, Becky?
Very much appreciated. Yes. Questions, reviews, keep them coming.
Absolutely, yep. We do always love to hear from you. So again, if you do want to get in touch, primarymathspodcast@twinkle.co.uk. That's Twinkle without an E, of course. Yeah, as Becky says, we would love to hear from you. Now, over the last few weeks, we've been thinking quite a lot about how lessons can become a little bit passive sometimes for pupils, particularly on the AfterMaths episodes. We've sort of talked a little bit around what it means to use a scheme and how to use a scheme effectively, and how we can encourage mathematical thinking in lessons, and how we can try and make sure that pupils are doing maths rather than sort of watching maths being done by the teacher, haven't we, Becky?
Yeah, that's come up a lot, hasn't it? Making sure that there's that level of engagement and not just on the surface, but there's actually something going on below the surface too.
Yeah, and that was sort of, I'm going to sort of wrap up that little bit that we've done on that over the last couple of weeks, and we'll move on next week to a slightly different topic. I was reminded of a conversation that I'd had with a Year 5 pupil. I was sat next to them as they were doing some work in a lesson while I was on a school visit, and I sort of asked them how they thought about maths, did they enjoy maths, that sort of thing. And she sort of looked at me and just said, "I'm not really a maths person." And I thought, wow, you are 9 years old, maybe 10 years old, and have already decided that maths just isn't for you. And you sort of hear that from adults, don't you, sometimes? I'm not a maths person. I know we've talked about it before. But I think it's particularly disheartening to hear it from children, particularly during
really
a maths lesson. Yeah. And I was trying to think, what has led to this point? And I don't know with that particular pupil, but I'm guessing it wasn't just a single event that had caused that to happen. I'm guessing it was kind of accumulated experience through probably not just maths lessons, probably experience of maths in the world. And we've talked a lot about maths anxiety and things before, and how having parents or people in your life who don't feel confident about maths can have an impact on your own belief about yourself as a mathematician, and those sorts of things. There's quite a lot of research to suggest that kind of identity can already be established by the age of 6, which is crazy, really, isn't it? But I do think maths lessons do have a role to play, obviously, because some children could be doing 5 up to 6 hours of maths a week at school. And the sorts of lessons that they are engaged with are clearly going to shape their attitude towards maths.
Yeah, I mean, that's very young, isn't it, to make up your mind that you're not a maths person. And by doing that, you're kind of closing off some opportunities in the future that you might have. But yeah, it's a long time doing maths, isn't it? If you've already decided you're not a maths person, that's a lot of hours in maths lessons.
Yeah. Can you imagine if maths is the first lesson of the day every day, and you've already decided that it's not for you, and you're starting that, you're starting every day with a lesson that you immediately disengage from. That must be hard. And I know we've all taught pupils who don't enjoy maths. Everybody's different. Everybody has their preferences. But I just think that there are things that we can do as teachers just to make maths more inclusive, perhaps, or to develop that sense of belonging in a class, and that sense of identity as a mathematician. Even just telling children that we're all mathematicians can, it's a very small thing, but how often do we say it? How often do we say, we are doing maths, we are mathematicians? Everybody in this class is a mathematician because we're all working on this. Just little messages like that even can make a big difference, I think.
I think that's almost like shared identity is helpful there. I remember when we first sort of adopted a teaching for mastery approach, and it was very much, whereas before it was very disjointed and people were doing different things, and it was not, we weren't in it together. And we talked a lot about that collaborative aspect and how it was like, we were all going to cross the finish line. It wasn't about just one person getting there first and together. And I do think that sort of like shared collaborative approach does help with that, I think.
Yeah, no, I agree. I think it hugely does, especially when everybody feels that they can contribute. And lesson design and task design, as we talked about with Will this week, and have spoken about with lots of guests actually, can contribute to that massively. If you have a task design that means that everybody, genuinely everybody, can engage in the start of, the first thing in a lesson at least, can contribute something towards that, then you are immediately driving engagement, aren't you, rather than putting up a barrier.
Yeah.
And I think I've spoken about this before. I was working with a teacher and we were looking at a lesson that involved 2-digit plus 2-digit addition, lower key stage 2 lesson, 2-digit add 2-digit addition. And the first question was something like 67 add 26 or something like that. And you just thought, we that for some children, just looking at those two numbers is immediately going to raise a bit of a barrier, isn't it? And we could have simplified that, and we did. We looked at it and we thought, where would be a more appropriate starting point? And actually, I think we ended up doing something like 19 add 10 to start with, or we may have even done 19 add 8 or something like that, so that we were looking at what happens when we cross that tens barrier initially, just recapping prior learning. And then we did something like 19 add 22 or something, and we looked at, we could redistribute the numbers to make it easier. But the whole point of it was that it was a low barrier to entry, and we had the manipulatives there as well. We started looking at we did the distributive thing with cubes, so that we looked at actually, the quantities aren't changing. If we just made that 19 into 20 by taking one cube from the other side, what would happen there? And we could see it all. Children were doing it. And it took a little bit longer, yes, to get to that learning goal of being, of everybody doing 2-digit add 2-digit addition. But the things that we noticed along the way made that journey so much more worthwhile, I would say, rather than, just going straight into a procedure.
Yeah, it's time well spent.
So it's those choices that we make, and this isn't getting at teachers. You know that, Becky. It's not that at all. I think the reason that we're pushed into that way of thinking sometimes is because of how much there is to cover, how many things a teacher has to do, the accountability measures. We're talking again with somebody this week about how, actually it was with Sally, wasn't it, our colleague earlier, about the multiplication check. And, we know that we want to teach multiplication so that it makes sense and there's conceptual understanding, but that is not what the MTC takes into account in year 4. It simply measures whether children can rapidly recall and accurately enter into a digital system, multiples to 12. And that's all it checks. That's all it tells us. That's not necessarily totally unuseful, but it doesn't paint that bigger picture, does it? And the same thing with the SATs. When you look at the arithmetic paper, what does that value? It values being able to follow a procedure very quickly and work accurately, which again is part of maths, but I would argue doesn't necessarily do the things that we're talking about here, which is, building that picture of a more rounded mathematician, and valuing thinking rather than just procedure.
Yeah, the things that make a good mathematician are the hardest things to measure, aren't they? I think that's the thing. It's easy to measure someone's procedural capabilities, less so to measure whether they're thinking like a mathematician.
Yeah, absolutely. And I suppose the way to encourage that is just those, as a teacher, just taking at the moment to say, rather than saying that's wrong, saying, can you explain how you've seen that, or that's an interesting approach, or anything like that, and just taking time to remind everybody that we are working as mathematicians, and that's the skill that we're, it's like in history, isn't it? We could either spend all our time in history lessons learning facts about things that happened in the past, or we could learn to be historians. And that, I would argue, is a much more rounded skill set than simply being able to recall the dates of major events. That has its place, but I think if you go on to study history at university or whatever, you're going to need much more than just some dates, aren't you?
Yeah, and if you're studying something, that's what you want to get from it. You don't want to just learn things that anybody could learn. I mean, I could tell you some key dates from history, but I don't have any qualifications
No.
in history. I'd like to think by doing one, I would learn more than just that.
I mean,
And
you
the
and I,
skills
Becky,
involved.
we both, funnily enough, actually studied law, didn't we? And
Yeah.
you remember dates are an important part of that as well, and case names and case dates and things. But those things on their own don't actually tell you anything that you need to know. You need to understand the context of it and everything else to be able to apply that. And it's the same with maths. I would suggest that you can know the facts, but we know that we need so much more than that, and we need to value those things. And I think if we can, and we can value that collaborative approach, then we're going to have far more children engaged in lessons meaningfully and feeling like they are part of that lesson and that they belong there. And, we shouldn't be having any children at 9 years old saying, I'm not a maths person.
No.
I know it happens. I do know it happens. But I think if we can do anything that we can to stop that from happening, then it's worthwhile, whatever that is.
Yeah, absolutely. Big responsibility, but then we know that teaching is a privilege and a great responsibility as well. But yes, certainly making those early experiences of maths as positive and engaging as possible, I think is key there.
Absolutely. And that's what we try to do here as well, isn't it? And one of
We
the
try.
ways that we do that is by giving you some of the background and history. History is coming up a lot today, of various mathematical concepts. And Becky, you have got some history of maths for us, I believe. I
Yes,
hope.
I do. So, yeah, yes, I do. So, this podcast episode is airing, as we said before, on Friday the 13th, but it is March, which means that the following day, Saturday, is actually the International Day of Mathematics, which is affectionately, of course, known as Pi Day, due to the way the date appears. It tends to be the American format. We tend to write it as 3.14, wouldn't we? We would do it the other way around, but 3.14 being, of course, the first three digits of pi. So, although pi doesn't really come into the Key Stage 2 curriculum, I seem to remember thinking about it for the level 6 sats, which is obviously a
Yeah.
long time ago now.
Yeah.
But I just thought I'd do a little history of maths / maths of life, tiny sprinkling of etymology maybe in about pi itself. Just because it's coming up, and why not? Why not celebrate it? Incidentally, also Albert Einstein's birthday was March the 14th
Oh, really?
too. Yeah,
Happy
it's one of those happy
birthday, Bert.
accidents.
Yeah.
So pi, I mean, we're all fairly familiar with pi now, but it was first used by the ancient Babylonians approximately 4,000 years ago. Of course, it
Those
wasn't
guys
known
again.
as. Yeah, here they are
They
again, the
loved a bit of maths,
Babylonians.
didn't they?
They
They
did.
loved a
They
bit of
did.
maths. So we came
Yeah.
across the Babylonians, I think, when we were talking about base 10, and
Yes.
time as well, and calendars. So, yeah.
And I think part of that is because they had some good recording. Stone tablets were found and things were found, so we were able to learn a lot about what was going on there. They didn't call it pi or use the symbol that we today would use for pi, of course. It was just known as the quantity which, when the diameter is multiplied by it, yields the circumference. Trips off the tongue.
Absolutely.
And going all the way back, it started as they were saying that the area of a circle was calculated by taking 3 times the square of its radius. So they were taking it as a
Right, let's
very
slow that down.
average
We've
3.
said that this is not a Key Stage 2 topic, Becky. So just for anyone listening who the last time they thought about pi was at secondary school themselves,
Shall I
I'm
do a
sure
little
for most
reminder?
people that was not that long ago, but I've been to bed since then, so it may have fallen out of my brain. What
Yes.
is pi? What is it?
So pi is a number. It's an irrational number, which I'll go into a bit more detail in a minute. But we use it mainly in circles to calculate the circumference or the area. So a reminder that to calculate the circumference of a circle, the distance around the outside, what we would call the perimeter, you would do the diameter multiplied by pi, this irrational number.
And the diameter is the distance across a circle through the centre.
Through the middle.
From one side to the other through the centre. So kind of the longest distance that you can go across the circle.
Yes. We can also use it to calculate the area of a circle. So in that case, you would take pi and you would multiply it by the radius. So that's half the diameter. So the distance from the center of the circle to the outside. You would square that. So the radius squared multiplied by pi will give you the area of a circle. So there was lots going on to try to work out what this number was. It's an irrational number, meaning actually it can't be expressed as a ratio of two whole numbers. And the decimal representation.
It's basically 3 and a bit, isn't it? But identifying that bit seems to have caused problems over the years.
It took a long time. So originally it was just 3. They were saying that it was calculated. The area was 3 times the square of its radius. But within the Babylonian time frame, eventually they got it accurate to a value of about 3.125 is what they were using at the time.
Wow. Okay.
The ancient Egyptians then, a little bit later, came in, joined the party, and they were using a value slightly more accurate, a 3.1605. So we're now going to 4 decimal places. And probably the most famous person when we're talking about pi is Archimedes of the Eureka moment. Wasn't regarding pi, but he did a lot of work around pi. And it was around the year 250 BC when he used Pythagoras, actually, to come up with the first algorithm, the calculation to calculate pi. And he worked out that it was somewhere between 3 1/7 and 3 10/71. So he'd narrowed it down both ways and knew that it would fit in between these two. So we're getting closer to what it would absolutely be. At the same time, there was a Chinese mathematician, roughly the same time, it was a little bit later, working on it, unaware of Archimedes' work on it, but was doing a similar thing to work out the algorithm, Zhu Chongzhi, and he calculated it correctly to 7 decimal places in around about the year 480. Wow. But they didn't call it pi. As I said, they described it as the number which would result in if you did certain things. So it was actually a Welsh mathematician, we don't mention the Welsh very often, called William Jones, who first used the Greek letter pi to represent it.
Stop the Babylonians and the Egyptians hogging all the limelight, and the Greeks.
Absolutely.
Get the Welsh involved.
Yeah.
Fantastic.
And the reason he chose it.
When was this, Becky?
Probably. So that was. Oh, actually, haven't got the date here, John. We'll have to find out. Maybe you could find that out for me.
Okay. Who what was his name?
William Jones. Well, the Welsh mathematician William Jones.
That is a great Welsh name, isn't it? William
Jones.
That will narrow it down for me massively. Thank you.
Yeah.
So William Jones was born in 1675 on the Isle of Anglesey, which I've had a couple of very nice holidays in. And he lived to the ripe old age of 74-ish. And died in 1749. So, his work on pi was around 1706. So,
wonderful.
320 years ago.
Brilliant. Thank you, John. Important point that I didn't quite catch in my falling down the hole earlier. And he probably chose pi because it was the first letter of the Greek word for perimeter. As simple as that.
Okay.
Or periphery as well. So nothing too mathematical there, just something that made sense. And now we, of course, know it as pi. It has been calculated to 62.8 trillion digits by Swiss researchers.
Just on the back of a fag packet, yeah?
I mean, I'm sure you would never, ever need it to that degree. In actual fact, NASA only use the first 16 digits when they use it in interplanetary navigation.
Really? Oh,
so it's good enough for NASA. I feel like 16 will do.
Yeah.
But
I'm quite happy with 3. or even 2, to be honest. It seems to get close enough.
3.14, I feel like
Yeah, that's
is
fine.
probably
Yeah.
close enough and
3
easy
and a
to
bit.
remember, particularly if you remember Pi Day. The world record for memorizing the digits of pi is held by Rajveer Meena from India. Would you like to guess how many digits he
It's going to
memorized
be
it
something
to?
ridiculous, isn't it? So we know it to trillions. It's not going to be trillions, is it? I can remember it to 2 decimal places. So somewhere between 2 decimal places and trillions, I would say,
Yeah.
Becky. Let's go with 120 places.
Many, many more than that.
Wow. Okay. Go on then.
70,000.
17?
70.
70,000.
It's in the Guinness Book of Records. 70,000. It took him over 10 hours to write it down.
Right. Did somebody check for earpieces? And I mean that seems 70,000, because the wonderful thing about pi, as you say, it's an irrational number. It doesn't repeat. There is no pattern, is what I mean. Certain digits obviously do repeat, but there is no repeating pattern within it. So he would have to have remembered. I mean, I'm sure he broke it up into chunks, but still. So that's
It's an
I struggle to
official
remember my PIN number, which is 4 digits.
Well, we've spoken about chunking the numbers up, haven't we? I can't even begin to think how you might chunk those numbers up to remember it. I mean, that's the official record from Guinness.
Well, you think other people might have beaten that for fun?
Well, there is an unofficial record,
is there?
which is 111,700 digits.
And why is that not official?
I guess there wasn't somebody there with a clipboard. You know, when you used to watch Record Breakers, there had to be an official adjudicator.
Roy Castle and his trumpet. And
a clipboard.
Yeah.
Yeah. So, I mean, that was, 70,000 digits. I can't even,
no.
Yeah. Why would be my question.
Yeah.
But, I mean, it's one way to get into the world record book, I suppose.
I think I'd do better at like smashing plates or spinning plates or whatever it was. How many baked beans can you eat with a
toothpick?
Toothpick. Yeah, that's the word I was struggling to find there, Becky. In a minute, I think I'd rather do that than remember pi to 70,000 places.
Yeah. I wonder if that was 2015, so 11 years ago. I wonder if that's something that stays in your head or not. Interesting to find out. Not much space for anything else, I suppose.
No.
Yeah. So a couple of interesting facts about pi there, and we do still use it. I mean, it's probably not used by the average person much, but we are using things that use it all the time. You can imagine construction, engineering, anything involving circles or cylinders probably uses it. I have used it before to calculate the circumference of a cake I'd made when I was trying to cover it with icing. You could, of course, say you could get a bit of string out and you could do it that way. But, I appreciated that it's quite satisfying to think, I could use pi here. That would be quite a good use of pi. So it does have a use.
Yeah. Whilst it's not in the curriculum, Becky, I definitely talked to my year 6 pupils about pi when we were looking at circles and naming the parts of it, diameter and radius and circumference, because why wouldn't you? Just because something's not in the curriculum, we want to give a purpose to learning these terms of the sort of anatomy of a circle, I suppose, and introducing a concept like pi, it just makes it, well, to my mind, makes it slightly interesting. I think pi is interesting. The fact that you can pull up on the interactive whiteboard pi to a million places or whatever and scroll through and show the children what that looks like. I think that is fascinating.
Well, it's awe and wonder, isn't it? That's the awe and wonder of maths, which we need to be telling children about and opening up their eyes to. I think, like you say, it's not in the curriculum, but why wouldn't you mention it? And would love to hear
whole lessons on it, but and they don't have to necessarily understand how to use it immediately. But the fact that you can talk about that relationship between the circumference and the radius, the diameter, and the area and the radius and things, totally.
Yeah,
and again, I would caveat
definitely
that
worth a
to them by
mention.
saying, you're not going to be tested on this. You don't need to remember it at this point, but this is something interesting about circles.
Yeah.
All that wonderful history. Just play this podcast to them. That'll be fine. If you want a quiet
Yes.
afternoon, a quiet morning next week in year 6, and you're doing circles at the moment, just play this. It'll be fine.
Yeah. I mean, it would become very boring, wouldn't it, if we were only teaching exactly what was on the curriculum and not talking about anything else that might accidentally slip in from real life.
Yeah.
Um,
As you know, Becky, my class, all of them, every single class that I've ever taught, have all been experts at allowing me to or to introduce a topic for me to go off on a tangent about, and take up a whole hour's lesson that was supposed to be on this, but ended up being on, as you say, pi or something historical. Often, they'd be very good at getting me to go off on a tangent about.
yeah, well,
While
it's
they
good
did very
general
little work,
knowledge.
and I stood at the front and talked to them a lot. Yeah,
And in
yeah.
the future, they may appear on a game show somewhere and need to know those facts, and they'll think, I remember when Mr. Cripwell told us all about that.
And when they do, if they could send me just a small proportion of their winnings, that would be great. I don't ask for
Yeah,
much, 10%,
yeah,
20%. Yeah, that's fine. That's absolutely
that's fair
fine.
enough.
I'm not going to take
Love
100% credit for all of their general knowledge.
I'd love to hear any examples of any listeners that have used pi in real life, because I think probably it does come up particularly if you're into DIY, maybe you've used it. So if you do have any examples, please do send them in. But yeah, there you go. Just a little snippet of pi to celebrate Pi Day, which happens on
You
Saturday.
might have used pi to calculate the ratio or the size of your pie dish that you need to make a pie. If that's the case, we would love to hear what flavour was it. That's what I need to know.
Yeah.
Savoury or sweet? Yeah. What's your favourite pie flavour, Becky?
I think we've had this conversation before.
I
It's
think we have
cherry.
to, actually. Yeah, I was about to say it's cherry, isn't it? Yeah. And mine is too. I'm going to have it with ice cream. Happy days.
Yeah.
So that is, believe it or not, Becky, pretty much all we have got time for this week. But thank you very much for that deep dive into pi. I really enjoyed that. And I will do my best to remember it. So for everybody listening, just a couple of things then to wrap up the episode. If you want to carry on the conversation, there's often quite a lively, engaged discussion happening over on my LinkedIn, which I'll pop a link in the show notes to. And we've also started sharing some slightly longer reflections and resources through the podcast Substack, which again I'll link below, but you can search for Primary Maths Podcast Substack and you'll find it there. And then just an exciting announcement, Becky, that I think we can make at this point. So we've sort of teased this a few times, and we need to do a slightly longer episode on it, I think, at some point, because I think it's interesting how we've got to this point. But at Twinkle, we have been working for some time now on completely refreshing the Planet Maths scheme of work that we have. And so every single lesson, it's not complete yet. It is a ongoing process of production to bring this to life, and a fantastic team of people working on it. But every single lesson and resource has been completely rewritten to reflect the latest research and pedagogy and approaches. And when I joined Twinkle back in April 2025, this was already well underway. But when I interviewed for the position back in the previous October, it was already underway as well. And I was delighted to hear that some of the things that I wanted to see in a scheme of work were already being thought of and included. So I've always been a great proponent. And again, we'll do an episode on this. We'll go into a bit more detail about it, because I think some of these things are pertinent whether you're using our scheme of work or somebody else's. But things like making sure that there are greater depth challenges throughout the lesson, not just a challenge at the end or problem solving at the end. Those things are in there. Problem solving is built in. And Becky, I know problem solving, we will talk about more to come on that very soon.
Definitely.
Exciting companion product to Planet Maths. we shall say no more. But problem solving is built in. Greater depth is built in. Scaffolding is built in throughout this new scheme of work. And what's exciting is that the first taster packs are available to download now, completely free of charge. So you can go and have a look at those, see what you make of them. And we would love to hear your feedback on those as well. So I will put a link to the taster packs that you can download in the show notes to this episode as well. And as I say, it would be great, I think, Becky, to have a little bit nearer the time, because the full offering will be available for September, but there'll be lots of units that will be available before that as well, so that you can have a proper look at them. But a little bit nearer that time, we will go into a bit more depth and detail about the thinking behind creating a scheme of work for maths, because I think that is the useful bit. And this is not my work particularly. I've had a little bit of input into it, but there's been a fantastic team working flat out on this for a little while, and it's really, really exciting. And obviously, Becky, we are some months before a refresh of the national curriculum as well, but I think we won't have to change a huge amount, actually, because we've really thought about what this will look like and how it will fit with the new national curriculum. Even though we don't quite know what that looks like yet, I don't think we'll have to change an awful lot. But obviously, we will make those changes when that is announced.
Very exciting news, John.
Very exciting.
It's been a very long time coming, but the team working on it have worked tirelessly, and like you say, so much has gone into it, which we can unpack later, maybe with some of our colleagues as well. But yeah, very exciting to see a taster pack available for people to have a little look.
Yeah, so if you want to see what that looks like, then, as I say, visit the show notes. It will be in there. That's all we have got for this week. I will be back on Tuesday with another interview episode. This week, I'm really excited to say that we've got an episode with Tom Oakley, who is a deputy head at the school, but has also previously been a maths advisor for local authorities and worked with maths hubs and things. And appropriately enough, Becky, we're talking about belonging in maths and how we can develop that sense of belonging. So that thing that we talked about at the start of this episode, there's some more hints and tips and thoughts on that with Tom on Tuesday. And then Becky and I will be back next Friday with another AfterMaths episode.
Yep. Thank you for listening, and we'll see you next time.
Thanks a lot. Take care.